plus what?
Plus 1.2.
1.2 plus exactly again 1.2. And how much is the answer? 95%. Awesome. So that's what's happening. The maximum efficiency for this transformer, for the new transformer, now is 95%. Does it make sense, guys?
Yes.
Is it clear for all of you? Yes.
I can't make it higher than this.
It is impossible.
What about if I use a better quality?
You are changing the transformer.
Okay.
I mean with the same transformer.
Okay.
If you are changing the transformer, of course it is possible. Why? We mean even if you change the voltage, it is going to be a different story. But we mean by changing the load. Okay. Is it clear, guys? And something else that so I think many of you had problem with this. So hopefully now it is all sorted. Something else, guys, that you asked me last time about full load, half load, and things like that. Now, for this transformer that we have, it is working in full load. So full load situation is given to us, right? Okay? So let me erase everything, and I don't want to talk about efficiency, but something else. Now, if we chip this transformer, use this transformer, we wanted to find not the maximum efficiency. We wanted to find efficiency at half load. Guys, efficiency at half load. Which formula we have for efficiency? The formula that we have for efficiency is always the same formula. Efficiency equals S out over P what? Cu plus PF. Right? So we wanted to use that. But now it is half load. So if it is half load, then what's gonna happen? First of all, Fe stays the same, right? PFE. Because it is fixed. Equals how much? 1.2. It's not changing. But how about PCU? PCU stays the same?
No.
Half?
Half a square.
Half a square, exactly. PCU 2 or mu equals whatever is this portion. Now it is 2, 1 over 2 squared. Times how much? 4. Which is going to be 1 kilowatts.
Right times 4.
It is given to, oh sorry, 5. Sorry. Which is going to be how much? 5 over 4 is going to be 1.2, huh?
25.
1.25, yes. Now, the new efficiency, half load, equals S out. How much is S out? Half load. So half that value. So half means that S2 equals 100 kilovolt ampere times half, 50 kilovolt ampere. So 50 kilovolt ampere, 50 kilovolt ampere plus 1.2 kilowatts plus 1.25 kilowatts. And the answer is how much? Times 100%. The answer is how much? Around 96%, 95%. Huh? The answer? We will have one of this question probably in your exam. Probably, maybe not.
95.5.
95.5%. Is that clear, guys? Any question about these things? Efficiency and stuff?
Yes, sir.
Yes.
Why we square the half?
Yes, because what's happening? Your load is now half. Your current is now half. It is series, right? So if your current is half, then I to R losses, your R is fixed, I to R losses going to be half squared, right?
So we can say just
Because now your current is half the current before, but remember, we have I2 times R. So if it is half, then half is squared, which is 1/4 going to be your losses. Does it make sense?
Is the half change or always half?
No, it's not always half. It could be quarter. It could be 1/10. It could be anything.
Okay, where do we get this half?
Just a question. Find at half level. The blue one is a question. Question sign that do it this way. So instead of half, I make you guys do something else. Find at 1/3 of the load. 1/3 means that 1/3 squared. So 1/3 squared times 5 equals how much? Smaller than that definition. 0.45. But how much is our load? 100 divided by 3, which is going to be how much? 33.3 kilovolt ampere. So 33.3 kilovolt ampere, 33.3 kilovolt ampere, 1.2 going to be the same, but here going to be how much? Going to be 0.45. How much is the new efficiency?
It's gonna be 95.2.
95.2%. Awesome. So, any other question? Radhika, you prefer to sleep. Yeah, that's what I said. We need some pillow here.
The class is very exciting.
Hmm?
The class is very exciting to me.
Yeah, same.
Is that what?
Exciting.
Exciting, really? It's good. Awesome. So you don't need a pillow. Okay. So maybe after the class you need some blankets. Okay. Finish? Understandable? Question about that? Can we go to the next page? Awesome. Okay, guys, the next page is about the model. What are two losses and things that we just explained right now? Have a look at that and quickly tell me if you have a question or if you want me to explain something. Page 16. All okay? Page 16. And then page 17. Page 17, we have a formula called voltage regulation. I explained voltage regulation, but first of all, look at other stuff that we have in page 16. Are you okay with page 16, guys?
Yep.
Okay, so now, page 17. Guys, voltage regulation is an indication to tell us that, okay, how much our voltage is changing. If our voltage regulation is small, because we have a percentage here, okay, is it good or if it is big? Voltage regulation, which one is better? We have VO, no load, minus VO, full load, over VO, full load. If it is a small, it is better, isn't it? That means that the difference between no load and full load is pretty close to each other. But if you get in a very big voltage regulation, then something is wrong. Means that you're getting a lot of voltage drop across your transformer. Okay. There is no question here, but if you found a question, we can go and answer that. So, for example, if you got a transformer in the secondary side of the transformer, we're not looking at primary here, just the secondary side of the transformer. If you are just get the transformer open, you're not using the transformer, open circuit, measuring the voltage, 230. But then you connect your transformer to a load, for example, requesting 14 amp, transformer is fully loaded, but now your voltage come and say it is 100 volts. It's not a good transformer, right? Because you have a lot of voltage drop over here in a full load situation. But if your voltage stays as 230, then your voltage regulation is 0%. V no load minus V full load equals 0. 0 over V full load, which is 230, 0. So that's just the concept of voltage regulation. But let's see if we have question of maths. Question, voltage regulation, what is it? Now, the next one is double wound transformer construction. It's about construction of transformer, guys. So you can have double wound, two different windings, one winding here, another winding here, or one winding here, another winding here, and in this between we have the core connecting them, or we may have auto transformer. Auto transformer means that we have the same winding. One winding, but we use that as a transformer. Compare auto transformer and double transformer. Do you have a question for me about that? Yes.
David said something about break,
Yes.
but I couldn't
Yes.
understand.
I told you again, but I'm telling you right now. Guys, auto transformer, one of the reasons that we don't use auto transformer for sensitive equipment is that break.
Yep.
What happening? This is the auto transformer. You pretty much have three areas. This is your primary, for example, and this is the secondary area. Now, what's happening, guys? We have pretty much three different areas, three different winding, you can imagine, but actually you have just one winding here, and the same winding, but you just have a portion of that winding. So, if a problem happens here, if in a common area, this is the common area, both windings using this area, if you have a break, then what's gonna happen? The primary gonna be equal to the secondary. What's gonna happen? Let's say that your transformer, you wanted to use this transformer for your mobile. Here you need 12 volts, but you get 230 volts across your
Second.
mobile. What's gonna happen? Fire. not explosion, probably is not
Smoke
gonna
or-
happen, but you have to buy a new one. Not a battery actually. You need to buy a new mobile. Guess if it is iPhone.
And what the connection, the line is one line, one wire.
It's the one wire, the same wire, but what's happening? This wire is connected to the middle terminal. The middle terminal. So that one is connected to this.
Connected to the winding.
Connected to the winding, yes.
The difference between it is a conductor.
Yes, it is a conductor, but these two conductors connected together. They are partially. This is connected to that.
So we need the core because it's connected with
What's that?
the winding.
Core is inside. Don't worry about core.
Yeah, I mean the wire coming from primary side is connected to the wire in secondary side.
Okay. So that's how it works. Let's say that it is the primary side. Okay. The same cable here. Okay, you have two terminals, right? You have two terminals in your primary and secondary. And here you're using the same terminal. The bottom one is the same, but the top one you're getting one of these cables. You're getting you will connect one of your cable terminal to one of these cables here. Okay. Does it make sense now?
Can you draw?
That's what I meant. This line is connected to here. Use this line is connected here. So this is touching that one, conducted together.
But that's why it's connected to the primary.
We have one wide.
Yes, you
One
just have
winding.
one winding. You just have one winding, yes. But yes, in middle of that, connected to your terminal
But
of
if we
secondary.
If we use one winding, that means the fault, the P primary equal secondary.
No, it's not equal. The same process gonna happen. Voltage going to be converted to flux, and then the flux going to be converted here. We're using the same winding.
And by using one that has two loads, there's two loads, one load of.
It's just one load. Your load is coming here in
Secondary.
your secondary.
The load, one become as a load of.
You're getting the same winding, yes. What about winding? What do you mean?
The one now it becomes as a load of.
No, it is not a load. It's a transformer. It's just a transformer, normal transformer. It's transforming, converting the way the voltage seems. What's the difference between these two with each other? They're not very different. If you have a transformer, also with double winding, the same thing gonna happen. This is one winding, and it is another winding. Now you're having the same winding instead of double winding. You're having the same winding, but now obviously you have N1, you have N2. N2 is part of N1. Okay, you got it? Then Muhammad, or you still haven't answered the question?
The idea that I have, there is no connection between primary and secondary.
Here we have connection. Here they are not isolated from each other. The transformer that you're saying, we call this transformer double wound transformer. This transformer is single wound transformer or auto transformer. Yes. Now what?
What happened to the car?
The current. The current is coming here. The current basically we have one current here, I2, one current here, I1, right? I2 and I1. And then you wanted to see that what's going to happen to the current inside the winding?
Yeah, because we request small amount of current.
No, it's not a small amount of current necessarily. This is your circuit. This is your primary current. This is the first, is one winding, another winding. Your secondary current, I2. Your primary current, I1. Let's say I1 is 10 amp, and let's say I2 is 20 amp. What's going to happen? This is I1, it's coming down, but you need actually 20 amp here. So if you need 20 amp, where that 20 amp is coming from?
Yeah, 10 ampere again from coming from there. Yeah.
Quite right, 10 amp here. But what's gonna happen if this side is broken? Then 10 amp going to here.
Just 10
Then
amp.
your voltage also going to be the same. Okay? Does it make sense? If it is not 10 amp, let's say it is 50 amp. Then what's gonna happen? 10 amp here, 40 amp. So because of that, guys, this side, actually, the common side is under pressure usually. We're getting more current from the bottom side. Does it make sense? The bottom side is actually compensating and doing the transformation for us. Okay? Make sense? Okay, so that's good. Any other questions? So you can see that there are some advantages, there are some disadvantages. The advantage is that it is cheaper because you just have one winding. Take smaller places. What's the disadvantage?
Okay, so
If the common
Exactly, exactly. It is not. And also you don't have isolation. As you said, because these two currents connected together, so you don't have electrical isolation. And obviously if it is broken, then what's going to happen? Then primary and secondary going to be the same. Okay guys, if we are starting a motor, it is okay. Why? Because your motor actually is designed to work with, for example, 400 volt. But you're giving it less voltage because you don't want grabbing too much current. Okay? But if you're getting too much current, you are not going to make a problem for the motor. You are going to make a problem for other loads. So David explained that last time in the last class. He said that if you do using direct online for your motors, what's gonna happen? You're basically getting too much current, and getting too much current going to make what? Going to make a problem in other loads. But it is not killing anybody. It is not going to kill your motor either. So it is okay. And this problem is not going to happen all the time, but maybe once per 10 years, once your transformer gone pretty close to death, it may happen. Okay? So it's okay. But how about your mobile or a small loads? It is not okay. Because they designed to work with, for example, 12 volts. How about transmission line? For example, whenever you're converting for example, 6.6 kilovolt to 230 kilovolt, it is not okay. It is not recommended and not okay because it's very dangerous if something like that happened. Okay, so are you okay with that? Now, if you are okay, so we can leave that. If you are not okay, you can explain it. Are you okay? So now, how about The next page, page 21. Are you okay with page 21? Is it making sense to you? What is it? So that's pretty much components involved in the transformer. So you can see that's how the heating happening.
All these diagrams are.
Understanding everything is important. Why not? If you're looking at one transformer, you need to know that what is that. As an engineer later on, very soon actually, then you may get some technicians, and then the technician come and touch the oil, for example, reservoir. What is it?
Reservoir.
Oil circulation and temperature.
But
Yeah,
those
we
are
can
based on
talk
it.
about that. But let me just tell you one of my experiences. Actually, I was working in a sugar factory, I told you guys, and one time I've been asked to take some people to show them the factory. Okay, I was electrical engineer. So we used to have a very, very, very big pan. You know what is pan, right? Boiling and doing things. Okay. And then suddenly one guy asked me, "What is this?" And I said, "Sorry, I don't know." Because what's happening, I never worked on that area. It was not related to electrical things. But really, later on I asked myself that, okay, I am working in this factory. This is the biggest pan that we have. And this guy asked me, "What is this?" And I don't know what is it. Yes, it is not belong to electrical, but at least I should know that what is this guy doing. So again, the same thing. You need to know at least what is this things, and maybe you are not going to open a transformer in your career. Maybe you do. Maybe you are going to design transformers, but at least it is good to know that what is each component means. So guys, what's happening? You already know that from power system 1, from electrical machines, that we use oil for cooling. Okay? So we have different process for cooling. Sometimes it is forced, sometimes it is not forced. If it is not forced, it is natural. So if it is natural, how things are working? We use radiator, yes, something like a radiator, exactly, radiator, and we use what?
Fans?
Huh?
Fans.
Yeah. So what's happening basically, if the oil is getting hot, it is going up. Okay? And if the oil is cooler, it is coming down.
By itself or
By itself, naturally, yes, naturally. What's the reason? The reason is that the oil that is hot is more, has less density, and is lighter. So it is going up. The oil that is cold, it is heavier, it is coming down. The same thing with the air. Hot air is going up, and then cold is coming down. So the same thing gonna happen in your transformer, and the oil is going to cool down your windings. Why you need cooling? You need cooling because of this stupid losses. Because these losses, they are heating your transformer all the time. And by heating the transformer, what's gonna happen, guys? You are increasing the temperature. So if this heat come and accumulates to the previous heat, then the temperature is going high and high and high. And the insulator that we use here is very weak actually. This could be paper or the other kind of insulators. So if you increase the temperature, you may destroy that insulation. And if the insulator is gone, what's gonna happen, guys? Your transformer is died, because it's just going to be a piece of copper. If all these windings stick together, then you don't have N. You just have piece of copper, and your transformer is dead. So you need to have a system to get rid of the heat. Make sense?
Yep.
So how it works? how it is look like. You can see how it is look like. So basically we have some tubes that let the oil to get circulated, and we have some tubes that let the oil, the hot oil, to go back to the reservoir. And we have a gauge, and the gauge is showing us that how much oil we have in a transformer, because sometimes the oil is leaching. So we need to know that if we have enough oil or not. So once upon a time, you need to go and have a look at your transformer and to see that if the oil is okay or not. Also, you need to look at quality of your oil and see if it is okay or not. Why? Because after sometimes your oil quality come and will be reduced, come to a stage that you need to replace your oil. Why? Because you have some arc. Still you have some arc between your windings, between your bushing and other things. So these arcs are going to demolish oil molecules and make some problem for your oils. Or you may get some dirt over there. The oil is cleaning this dirt, but it is getting dirty as well. So at that stage, you have to replace your oil.
How many or how much the oil in the transformer?
Depends how big is your transformer.
The biggest one.
I don't know.
Because
What's the
I've
biggest transformer?
heard
Could be.
from David, he said around 700 tons.
Yeah,
Could
so-
be.
Yes, could be more than that. Yes, not. Yes, so it is a lot of oil. That was actually, yeah, the first thing that I did as an engineer, but I was a trainee at that time, was changing oil of transformer. So they asked me to go on top of transformers and change the oil, which was very smelly and dirty, but that's okay. I learned something. So yes, it could be quite a lot of oil. This depends on the size of the transformer. Any question about this?
John, do we need to know all the specifications of the heat profile?
You need to know. You need to know some of this specifics. And believe me, it is not difficult. Guys, I told you something, and I am repeating that again. You don't need to know that every single point. But instead of that, you need to use the what? You need to visualize things. And by visualizing things, then what gonna happen? Then you can understand the process. For example, just visualize things that you are using oil to cool down your transformer. So where this oil is coming, you need to do what? You need to have a reservoir, something to hold this oil. Then you need something to show the oil. Then you need some tubes. Then what happening? So you can visualize things. Use your brain efficiently, in a good way, in a proper way. Learn how your brain works, because your brain doesn't like information that are not connected together. Your brain like information that means something. And that's the way that we can remember them. For example, now, if you ask kids here in New Zealand, everybody remember Old MacDonald had a farm, or I don't know about Saudi, could be some other songs. What's the reason? Because there is a relationship here. It makes sense that, okay, Old MacDonald had a farm, and then in his farm he had these animals, and then it's for practicing. It is quite difficult actually. Lots of these songs are extremely difficult, but your brain can understand them because there is a relationship between them. Make a relationship between all these sentences and understand the concept behind. Believe me, it is not difficult. Okay, can we move on? Page 45. Oh, which page is it? This one is different than that one.
Anyone? 22.
22, sorry, exercises. This exercises are a piece of cake, but if you want me, I can take some part of the cake. Okay. Question, exercises, and things like that. Do you want me to look at question 6? Question 7, any of these questions? I can see that Hassan indicated question 13. There are some questions, go ahead with these questions. Question 13, define the term voltage regulation. So Hassan already described that. Copper losses and other kind of losses, so I think they are okay. And we have the answer to exercises, so if they don't make sense to you, obviously I'm available to explain them. There is a question about voltage regulation, question 11. If you want me, I can answer that. If you feel it is easy, we can save our time and talk about other things.
Yeah, the answer is ready.
Answer is ready. Does it make sense? This is the point. Is it easy to understand?
Yep.
Uh-huh. Okay, so that's to me. Question 12, again Hassan indicated in your book, because this is the way that all of you need to do. Very good job, Hassan. So get one, you need to write in your book, this is your book, you need to indicate where you messed up, because learning going to be much easier if you write something or indicate important points or just about page 33, there is a mistake here, and the mistake is that it is saying that efficiency equals P out over P out plus losses. It is not P out, it is S out. S out over losses, because for transformer we always talk about S, not P.
Yeah, you
For
mean
us.
that S out over S out.
Yes. Then we have transformer calculation and exercises part 2. Again, guys, if you wanted me, I can explain them, any of them, or we can leave them to you, and then you can come back to me anytime, and we can go through these questions. So, yes.
The efficiency question is over is plus listen. It can be add is to the B. It's okay.
S out
Over
S out over P 50.
because the units
What's the question?
the units of S and P is different.
Yes, the question we ask, yes, we have, because actually kilowatts, kilovolt ampere reactive pretty much are the same thing. But we just wanted to discriminate real power with what? With the reactive power. Otherwise they are the same. Yes, we can do that. Of course we can do that. Yes.
Question number 6.
Question number 6. Which page is it? Question number 6. A transformer 250 kilovolt ampere has an iron losses 5 kilowatt and a full load copper loss of 16 kilowatts. Calculate number 2, load at which maximum efficiency occurs. Because this question is exactly similar to one of these questions that we answered, so I'm happy to answer that. So we want to calculate the efficiency where what happening, maximum efficiency is happening. So what we need to do, we need to say n equals square root of PFE over PCU equals PFE is how much? PCU is
Sadness.
15,000 or 10,000? 15,000? 16,000. The answer is
56.
0.56. So, yes,
3
maximum
36
efficiency equals
هذا الجواب هنا بس
0.56 times. How much was the full load capacity of the transformer? 250 kilovolt. Equals how much? Now, max equals output 140 kilovolt ampere over 140 kilovolt ampere plus these two plus 5 plus 16, which is going to be the answer. How much is it? Times 100%. Equals 87%. Is it clear, Ahmad?
Yeah, but what's the difference between 3 and 4?
Oh, okay. You wanted a difference.
Because they are the same.
3 and 4, maximum efficiency. Okay. 3 ask for, yeah, we combine them together. 3, load at which maximum efficiency occurs. So we answer the question here. Load at which maximum efficiency occurs. So that's the load where or which we got the maximum efficiency. But then 4 ask for maximum efficiency itself. So how much is the maximum efficiency? We calculated that. Okay, makes sense? Now, can we go ahead? Can we go ahead? Introduction to three-phase transformer.
Yep.
So, first of all, it is a three-phase transformer, so it's not a big deal. How it is look like? We have different components, different parts. Then components being listed here. Hassan actually listed the component, the core, the tank, transformer, oil, cooling system, bushing, explosion vent, the Buchholz relay, breathing system. Okay, yes, that's what Hassan listed from these components. And then he mentioned about cooling systems, on off, and other stuff.
I didn't understand some part.
Yes.
Page 41.
Page 41, okay. What is the part that you couldn't understand?
The fourth usually the one in the lower holding to the case
Usually, the one thing having the lower voltage to the earth is located nearest to the earth's core. And insulation from it, wrapping. So now what's happening, guys? We have two windings, right? One winding is high voltage, another one is low voltage, correct? So the one that is low voltage, right, needs less insulation, isn't it? So can be closer to the earth. But the one that has high voltage needs more insulation, right? So that's the point. Otherwise,
What is the core? Earth core?
Earth's core. So what's happening, if you look at that, this part is connected to the earth, the bottom one connected to the earth, right? If they are connected in serial, and if they are connected in a star. So if they are connected in a star, how it works? How you're making your transformer? It is basically can be 3 single-phase transformers, or it could be a 3-phase transformer. So if it is a 3-phase transformer, that's the way that we're making it. Iron here, iron here, iron here. So you have 3 windings. The windings are going to be here. This the bottom one is connected to the earth. So we can call that the earth core. So what's happening, it is better. The one that has higher voltage, to keep it a little bit on top compared to the one that has a lower voltage. This lower voltage requires less insulation, isn't it? So it's all about safety stuff. But okay, lower voltage need to be get insulated, but less than higher voltage. So better to keep the higher voltage on top compared to lower voltage. Okay? Any other thing that you guys wanted me to explain? And obviously the transformer itself, all this transformer is on a ton of oil. So we have oil here that's floating on the oil. And we use the oil both for insulation and also for cooling, exactly. So methods of cooling, we talk about methods of cooling. I think it is not a big deal here. Guys, look at other parts, page 43, 41, 42, 43, 44, 45. They are all construction. 47 until 49. Tell me if you have any problem or if you have something that you wanted me to explain. So they are construction, talking about construction. You really don't need to go to very detail over there, because actually electrical engineers usually are not involved in designing this kind of materials, laminating and things like that. Why? Because you need a special knowledge. You need this knowledge on metallurgy. You need to be a metal engineer to sort of go through these materials. We usually order these things and we want people to sort of look at that side from us. Okay. If you are okay with that part, and if there is no question, we can look at 3-phase connections. I already explained connections. We discussed that and I told you what is different connection means, and then we have list of clocks and things like that here. So vector groups and things like that here. So please have a look at them until page 54 and tell me if you have difficulty understanding any of this stuff.
Okay, and
Yes.
what about the 45 and 46? Do you need to know anything?
through it, and you will understand what you need to know. I can say that it is less important than other stuff, but it is still important. But just read through it and just understand that what is it. But obviously, I'm not going to ask you about numbers. I'm not going to ask you, for example, how thick is that?
What
or
about David? Will he ask us?
he might ask you specifically. Ask Muhammad a question for Muhammad. So we are going to get, for example, 20 questions, but 21 questions just for Muhammad and Samak. Okay. So I can see Hassan has 2 questions on basic theory. Hassan, do you want me to explain anything here, or it is sorted now? Good choice. You have 2 questions here. Yes. Page 49. Is there anything you want me to explain? Yeah, this video, quality of this video is super high definition, but the question is that how to upload it. So, or maybe I can just stop it here.